Okay, so we'll begin with the session. I'm gonna just share my screen. Um, can you see my screen? Can you hear me well? Can you see my screen? Can you hear me well?
Yeah, I can hear you.
Yeah, okay, thank you. So today we're talking about can we actually colonize our solar system and how would that look like? What will the challenges be? Are there any actually programs that are trying to colonize the moon or Mars, for example? And it's actually a crazy thought because statistics shows that actually 99.9% of our solar system is basically uninhabitable. Uh, and how when we know this, how can we even think that to colonize other planets or the moon when 99.9% is uninhabitable? And is Earth our only home for now, or will we be able to colonize other planets or other moons in the next 100 years, for example? Um, so yeah, we're gonna explore those questions right now. But first of all, why should we colonize? Basically, it's mostly curiosity. It's in our DNA to be curious. From cavemen to now where we are now, it is just curiosity led us to here because we asked a lot of questions, and this curiosity motivated us to actually try and find answers to those questions and see where that will take us. And from being cavemen to living in caves and hunting for animals for food, now we live in apartments here or in houses, and we're able to connect to people all around the globe. But of course, that's not the only reason. Of course, we have the backup for humanity. This is basically we, if we know, in the past, the dinosaurs, for example, they were kind of like because of the meteor, all of the species were endangered and they disappeared. And the same is with us. We don't know where when a meteor might hit us, and we could have not detected it. So we are endangered, for so to say. So if we notice a threat that we cannot really sort out and remove, we will have to have like a backup planet or a moon to go to and kind of like protect our species. So in today's presentation, we'll cover like different kind of types of colonization that we have. First, we're gonna do the near Earth space. This is basically the moon, different stations, the Mars, of course, then some other planets in the solar system, and how we may colonize them if we even could. And of course, not of course, asteroids. This is also an interesting topic. And then we're gonna also kind of like look into other missions that are ongoing right now to kind of like get us a step closer to colonizing Mars or the moon. So first we've got the station. So this is the ISS, the International Space Station. This is, if you don't know, it's basically a giant station, a spaceship, so to say, that's orbiting Earth really fast, and it's been doing that since 1998. And astronauts are sent to the International Space Station to live for around 6 years. It depends, but most of the time it's 6 months, not 6 years, 6 months. And they basically live in zero gravity. There's no gravity there, artificial or anything. So their life is actually really interesting and really different from ours. For example, they don't eat like from a plate with a fork. They eat from vacuumized packets that are already tested back on Earth. And they do some testing, they try it out, see what works, see what don't. and they kind of see if this would be, first of all, tasty and a practice for actually being sent to space for astronauts to eat. Then what is the most interesting for me would be that they actually don't sleep on beds or something like that. Sleep on sleeping bags that are actually hanged on the wall, are hanging from the wall, and basically they just dip themselves into the sleeping bags and sleep throughout the night very comfortably because in zero gravity they're basically floating around and just being strapped to the wall basically. And on the space station, they actually also make kind of like short videos about how they do things on the space station. And one of them mostly does, well, these videos mostly does Chris Hadfield. He was there once or twice in the space station. He's very popular. He actually did a music video there, playing on his guitar on the space station. So yeah, here this is a video of him explaining how we may actually look on the space station. Short. Yeah. You can see the water actually around the clock. It's not like falling out because there's no gravity there. Here it kind of goes into his hands. And yeah, this was basically the experiment, and kind of like to show you that on the International Space Station, there are actually different rules apply, so to say, because they are in space and there's no gravity there. So they have to do a lot of things very, very differently from what we do here on Earth. And why I'm telling you this is because such stations can be built to kind of like not only for experiment but also for actually humans to live there, and not humans, but civilians to live there. And they can be orbiting the Earth or the Moon or other planets as well. And there are actually some hypothetical designs like the Neil cylinders or the Stanford towers and the Burnham spheres. So this is the Neil cylinders. This right here is the whole thing, so to say, and this is like kind of the interior, interior. What it will look like if it existed, because it's purely hypothetical. This is basically two cylinders that are rotating to create artificial gravity. And what is interesting is that they actually built from materials that are from the moon and not from Earth. Next, we have the Stanford Torus. This is basically kind of a ring-shaped habitat that can contain up to 10,000 people. And it is a ring shape because it minimizes the amount of mass that required to have the same area and radius for rotation. And this rotation is needed again to provide the artificial gravity. And it actually, if you see here right here, it has a like a giant mirror. It is to reflect light off of it to the kind of the ring shaped station to provide natural sunlight. And this kind of in the interior. And lastly, we have the Bernal spheres. They are hollow spherical habitats, and their capacity is actually a lot larger. It can contain up to 3,000 people. And what is interesting about it is that there's actually breathable air inside, and it doesn't rotate to create artificial gravity. But all these stations, so to say, are kind of purely hypothetical, and there's no like we haven't tried to make them. So next we'll expand to the moon and um, how we can colonize the moon, so to say. So we know a lot about the moon. We have done a lot of missions to the moon. We have done a lot of spacecrafts to the moon, and of course we have the Apollo missions where people actually landed and kind of gathered dust and particles from it and brought it back to Earth for experiments. And we found from such experiments and such missions that there's actually water, not water, but ice on the polar caps of the moon. And this water ice is found primarily in permanently shadowed regions, which are also called PSRS, which are near the lunar poles, and are extremely cold and never receive sunlight. So basically, these poles, because sunlight never reaches them, they're extremely cold and contain ice. So this ice is mixed within the lunar soil, or it can be also buried underground. And its presence is confirmed by instruments like NASA's Mineralogy Mapper, which is also called M3, and it's considered a valuable resource for future lunar explorations, potentially for drinking water, and also rocket fuel and air, of course. So this is basically the first stage of colonizing, probably the moon, for example, kind of try to understand what the moon or a planet kind of like what rules apply to it, what's on its surface, what can we use, what can we not, what problems might appear if we want to actually live there. Yes? Comment, you have a question? Yes?
Yeah, I want to ask something uh, regarding the moon. I was saying that if we are moving ahead to the colonization, if we seeing towards Mars, so can we say that moon is like the natural space station for us, the first stepping stone?
I was going to say, yeah, it is kind of like a checkpoint. If we want to go to Mars, for example, we will have to first go. No, we don't have to, but it will be easier if you first build kind of like a base on the moon, and we fly to the moon first, and then from the moon we kind of like get more supplements, more materials, and then from the moon we go to Mars. Yeah, I was going to say that actually, and yeah, it's a great question. So yeah, that's the first kind of like first step, understand the moon or the planet. Then the second step is kind of like test how colonization may work. We sent basically small crews up to 12 people on the moon for in this case, and they kind of like build a small base that has to be in a natural shelter, for example in a crater or in a cave or underground, so it can be protected from for example meteors. um, so this potential small career would have to kind of like use machines and different systems to kind of purify the ice on the caps and make it drinkable for us be able to drink it and be able to use it for different for example for watering plants and kind of growing food, for example. um and yeah, kind of like test out how things would work out. But the problem with the moon is that during the lunar year, which is 14 days, there won't be any solar energy coming. So the solar panels won't be able to make energy that we'll have to use. So this potential crew will have to find a way to kind of like store energy, or they will have to just return back to Earth and then return back to the moon on the day. And then if everything's a success, if everything's turns out to be great, to work out, then we can think about actually colonizing it, so actually bringing people to the moon to actually live there and not returning. Um, and yeah, to be like a permanent habitat. But as we already said, the moon is not so much for a habitat, but more for kind of like a stepping stone for a checkpoint from the moon to the Mars. But we already explained that. So yeah, here you can see on the map. These are the caps, and blue spaces right here are kind of like the water, the ice that is underneath. Next, how can we colonize actually? How can we colonize Mars? Well, for now, again, we know a lot of stuff about Mars, about its atmosphere, about that there's actually again ice and water on the caps, and it's there's actually been found water underneath the surface. But still, there are a lot of probably more problems than with the moon to actually be able to colonize Mars. For example, the atmosphere. Of course, it's very thin and it's actually mainly contained from carbon dioxide and very, very little oxygen. Also, there's very high radiation because the atmosphere cannot protect from radiation, and the temperatures are very low. So, but if we kind of like ignore these problems for now, another problem that we will face is actually the solar power, which will be if because if we place solar panels on Mars, because Mars is so far away from the sun, the solar power will be like 40% of Earth's. And also then we have also sandstorms that are giant storms that bring a lot of dust and sand all over the planet. They basically kind of blur the whole planet because of the sand. And if this goes onto the solar panels, they won't be able to work properly. But we have possible theoretical solutions to most of the problems for now. For example, about the power, the energy source. Of course, we won't be able to use wind power or solar power only for that because there's not much wind there, and solar power, as we already said, very little. So we'll have to use nuclear power that we'll have to bring from Earth to Mars. And for the oxygen, we will actually kind of like use different systems first to purify the oxygen that is already in atmosphere and also create artificial oxygen, which will be created from nitrogen and oxygen. So, but if we use this oxygen, we kind of like put it inside the buildings on Mars, so to say, it will basically force them to be kind of like spherical because of the pressure inside from the artificial oxygen and outside from the carbon dioxide. Also, the radiation, for example, the problem of radiation, we won't be able to actually go outside and walk outside for long periods of time because the radiation is very harmful and a lot. And it actually increase the chance of cancer by probably 50%. And also, it can be also very deadly. So we'll have to stay mainly inside, but even the buildings cannot protect us fully from the radiation. So we'll have to cover them with first a layer of ice of carbon dioxide, which can be easily got from the atmosphere. And also, that won't be enough. So we'll have to cover this ice structure also with dirt and rocks. So it kind of creates this base on Mars. So that's the problem with radiation. And for us, because we won't be able to go outside to actually kind of dig up soils and materials and stuff like that, we'll have to have like Mars rovers on and robots to kind of like do that stuff for us outside. But then again, there's the dust problem because we'll have to kind of protect these machines from all the dust that will come inside and kind of break the mechanism. So there are a lot of problems, and if I have to be honest, for me, I think that life there won't be very possible, at least for now, with the knowledge that we have now and the solutions that we have right now. Because this would mean that we have to stay in houses with no windows for eternity, basically until we die, with artificial oxygen, not being able to go out to talk to other people except the ones you're with the building. And it's a isolation basically, and it's not great for your mental health or your physical health as well. So as you can see here, this is a Mars rover. As you can see, these panels right here, these are the solar panels, and if dust, because this is the dust storm I was talking about, if this dust goes, and it will, if this happens, it will go on these solar panels, and it won't be able to supply energy for it to work. And this is a potential kind of like hypothetical, how may a base look like? Uh, yeah, artificial environment, but it is not like Earth. I mean, um, every what do you mean by everything being artificial? Because it kind of is. The oxygen is artificial. Uh, basically only the plants that we are probably going to able to grow on Mars are not going to be artificial. But what do you mean by that? Creating artificial environment?
I mean, we can create everything artificially, like artificial soil. I mean, we can bring a little soil from Earth and create an environment just like on Earth, so that we can no radiation from the harmful environment on Mars.
Yeah, yeah. Well, that's basically what we do. We create artificial soils to create to actually kind of try and grow plants. We create robots to do our work for us. We create these buildings covered with ice and dust to protect us from radiation. And we create artificial oxygen to breathe. We cannot just bring some from Earth because it will cost a lot of money, and it is pointless at some point. So yeah, we have to find a way, but for with the knowledge that we have now, I think that we won't be really able to do that at this point in time. So it is a potential base, but purely hypothetical. Um, so next we're gonna kind of like explore um the different planets, how we may use them to kind of colonize them. So Mercury, this is the closest planet to the sun. So this means it's very hot, extremely hot there, and there's a lot of radiation because it's so close to the sun. So it's not suitable for life, but it will be a great source of energy because it's so close to the sun. If we place basically solar panels, for example, on Mercury, it will be very easy, and the energy source from the sun will be a lot greater from what we get right now on Earth. or what we'll be able to get on Mars, for example. So it's a very valuable source of energy to harvest as energy. Venus, this is actually a really interesting one. So even though its surface is extremely hot, like 850 degrees Fahrenheit, and its pressure is 90 times piece of Earth, it's basically not habitable. But if we go at about 55 kilometers above the ground, we will find actually a place that is pretty Earth-like. The pressure is pretty much the same, and the gravity as well. And because of this thick atmosphere that's full of these gases that are very harmful to us, it is able to actually protect us from the radiation that Mars could not protect us from. So they're kind of like ideas, purely hypothetical, of kind of like floating cities that are above ground, 55 kilometers above the ground. But of course, they're more kind of like sci-fi and not very theoretical. So this is kind of like an example of such city or such a building that is floating on above the ground. So outer planets. This is basically Jupiter, Saturn, Uranus, and Neptune. So Jupiter and Saturn are gas giants. This means they're made of hydrogen and helium and do not have like a surface that we can step on. So it's basically not possible for us to kind of colonize it if there's no solid ground to step on. Then we have Uranus and Neptune, but they're just way too far away from us, and are icy giants, which means they're mainly made out of rocks, ice, and water, which is mixed with methane. But they're too distant for us to be able to colonize them. They're too far away from us. So, next we have asteroids. And asteroids are actually a very valuable kind of like a resource for us to be able to get us, just like Mercury, for us to be able to get water and materials. And actually, a few years back, kind of like a spacecraft returned from Bennu um, with kind of like samples from the asteroid. So later when they kind of like searched and kind of like did experiments on these materials, they found out that there actually is water, and they are 40 of the 20 amino acids that are actually here on Earth that are able to build life. So that was very interesting, and it kind of led us to the thought that there might be able to be kind of like we can use them for resources, but also another option is that we can kind of like use hollowed out asteroids in kind of this creates like a cup, so to say, a bowl that kind of protects us from it's a natural radiation shielding. It kind of like protects us from radiation from the sun. And it can be basically converted into a radiating space habitat. And this is kind of like when the spacecraft returned, this is what came back with like a parachute. And it was really great. You can watch it on YouTube, I'm pretty sure. And inside was kind of like dust in the rocks. And now we are going to talk about more like missions that are ongoing right now for such experiments and such um, kind of like colonizations. So Artemis, it's actually going right now, and it's actually started. Its goal is basically Artemis is basically a complex mission that will enable human exploration at the moon, and basically because the moon is kind of like a stepping stone on Mars. So the first Artemis mission was in 2022, and it was basically a test flight. There was no crew on the board. It was just basically the rocket flowing away from Earth and orbiting the moon and then returning back. But no crew involved. It was purely like a test flight. Then in in 2026 is next year in November, I believe. A crew will actually be sent into space to orbit the moon. They will not land, but it will be kind of like a test to be able to land on the moon. But there will be a crew. There will be I think 5 people who will go into space and orbit the moon. And then there's a third Artemis mission that will actually its goal is to actually send a crew on the moon and for them to be able to land and to kind of and it's basically the first landing since 1972 when were the Apollo missions. They will be sent to the lunar South Pole where the water is found. And then there is the fourth Artemis mission, which is actually the most interesting, at least for me. Its goal is to kind of build an ISS, the International Space Station, but for the moon. And this type of station is basically called a lunar space station. And this lunar space station will be called, if it's created, but it probably will, it's going to be called Gateway. So it'd be kind of like a space station around the moon. And here, this is Gateway and how it will look like. This is the Artemis rocket, and this is the crew that is for 3.5. Sorry, this is the Artemis crew that will actually fly next year and orbit the moon. And next we have Chapea. This is not a mission on its own, but it's kind of like a simulation led by NASA. This simulation basically sends this it doesn't send people or astronauts into space. It's actually kind of like a base on Earth that 4 or more volunteers are sent inside, like a crew, but it's purely a simulation, and that's why not trained astronauts are sent in, but civilians that again highly trained, but are still civilians. And it's like basically a Mars-like habitat. It's like these buildings that I described earlier, how they would look like, what they would do. They kind of like perform different activities. For example, they kind of prefer simulations on walks on Mars using VR. They also do different experiments and testings. And it's kind of like its goal is to find how this will be on the mental health and the physical health and what problems they will face. They're sent there for an entire year. Only these 4 people, no more. They don't have connection to the others. And also another interesting thing is that they actually also simulate the signal that is because if we send a signal from Mars to Earth, it will basically take 20 minutes to take from Mars to the Earth. So they simulate even that. So it's a very high simulation. And that's it, the first mission. It was in 2023. But then there are planned missions for Chopea 2, which will be in 2025, and Chopea 3, which will be in 2026. But of course, these are not the only missions, Japan, the Artemis. There are also other missions. Its goal is to again learn more about space, more about how we may colonize these. And it's not only in America, not only NASA, not only SpaceX, but also China, Russia, and other countries around the globe work towards this problem. And yeah, there are several missions. I think this year there are 3 or 4 that are sent to Mars and to the moon. Um, yeah. So this year is the crew that was yeah. You Mohammed, you have a question? Yeah. What's your question?
Am I audible now?
Sorry, I wasn't able to hear us. I guess something was wrong with the internet connection or
So, am I audible now?
yeah, yeah.
Yeah, so I want to add something to the previous slide. Like as you have mentioned also, like the rest of the 4 planets of the solar system, they are the gassy giants. They are not the rocky planets. So they are not the habitable as we already know. So what about their moons? Some of the planets have around 80 to 50 moons, like Saturn and even Jupiter. And Saturn's Titan moon is kind of have some kind of favorable conditions to support life. So do you think what's your
Yeah,
perspective on habitating those moons of the planets? Yeah.
yeah, well, around, for example, Europa or the moons around Jupiter. For example, Europa is very like kind of like we look into it right now because we think that there's actually water on it, ice water, and there are multiple spacecraft sent to it actually to kind of like examine it and look into it and if it's maybe habitable and if there's life there. But yeah, the four main moons on Jupiter are actually right now very kind of like popular in this topic, like colonization, life on other planets or moons. So yeah, it is very the moons, especially Europa. So yeah, thank you. That was a really wonderful question. So yeah, here we got the career that was saying this is basically in Texas, America. It's based, but it's very high on how it will look like. This is inside. It's kind of looks like where the experiments are led. Kind of what will they do on this? What experiments they will do? So yeah, this leads us to the discussion topic. And could floating cities on Venus ever become a reality? So what do you think? Is it too far away from us, or is it actually possible for us right now?
It could may become reality, but it's far more than real.
Yeah, I'm on the same. Like, I think that it is possible because basically everything is possible at this point, but not with the knowledge and with what we know right now with our resources. Basically, probably in the future, but right now I don't think it is really a reality. Just more of a
Yeah,
great
actually,
topic
some
for a
unforeseen
movie.
conditions we don't know actually.